So with that, I'm Sal Furino. I'm a customer reliability engineer. You could find me at sfurino at most places, whether that's Twitter or on Mastodon, etc. And I'm here to talk to you about 9 things you should do when you're starting to use SLOs. Let's start off. Question here. Who's over here? We see 3 different books up here. We see the SRE book, the SRE workbook, and the Implementing Service Level Objectives book here as well. Let's do show of hands for each book. Who's read the SRE book here? Okay. How about the workbook? All right. And Implementing SLOs. Okay. All right. We got a good amount of folks here. So with each of these books, I feel that they are directionally correct, but still how to achieve SRE is an exercise left to the reader. And what I mean by directionally correct is that these were books generally written by Google for Googles, and hey, newsflash, not everybody has Google-sized or shaped problems. Another poll audience here, after reading these books, did you exactly know what to do to start implementing SRE or DevOps or something like that? Okay, all right, I got 1 or 2 hands there, thanks. But when folks generally read these, they start to chart their own path. They kind of build their own SRE adventure. They take bits and pieces of the knowledge that resonated with them and implement themselves, and they have mixed success doing that. And with that, I'm going to pick one small subset of the vast amount of information covered in these books here and talk about SLOs. And that's pretty much the motivation for this talk. So SLOs are hard to get right. Common questions people ask are, which metrics best instrument this service? What's a reasonable objective for it? How should I use my error budget? Who else needs to understand these signals? There's so much literature out there describing what SLOs are and how to calculate them and so forth. However, using them is sometimes a bit hard or left for people to figure out. And I also feel SLOs are like a cornerstone for incubating SRE and observability culture at organizations, and that can sometimes be challenging if you're not sure how to really use them effectively. And folks generally sometimes need additional guidance, and that's a lot of what I did as a CRE was coach organizations and how to get the most out of SLOs they do create. Which is really important because SLOs can empower conversations, they can enhance your understanding of a mental model of a service, and they also can dictate what actions you take towards reliability. Sometimes people try to avoid this, but there's sometimes a song and dance that people avoid trying to say that SLOs are a culture change, but they truly are. It's a change to adopting a more an organizational culture that makes more data-based decisions. So here's a quick overview of the 9 things I'm going to go over. I've broken them down into 3 groups of 3, and that's understanding systems, understanding expectations of systems behavior, and recognizing when a system doesn't match those expectations. So the reason why I picked these is that I've witnessed many organizations encounter stumbling blocks while attempting to implement SLOs, and we're kind of going to go through a way that kind of makes sense to help people along in creating them. So first off, understanding systems. If you don't understand a system, how can you measure it effectively? A lot of what understanding systems is about is drawing out details about a service and unpacking some of the assumptions we have about them. Hopefully, these 3 tips can give you a better understanding of what your services are and how to measure them effectively. The goal is to have a well-understood, high-quality signal that you can use to make decisions. So first off, measure meaningful things. SLOs shine a light on what matters most to users. When engineers start SLOs, they generally gravitate to metrics they already know: CPU utilization, disk I/O, bandwidth. While these signals are good for scaling and figuring out if a service has a bottleneck, generally folks should try to pick higher value signals that target user journeys, meaningful interactions with the service. Here we're going to go through an example of a service architecture and briefly talk through how a collection of services contribute towards a user journey. So first off, example customer here. All names have been changed to affect those who are unreliable. they're in the finance industry. They're a card processor. They have contractual and regulatory impacts for being reliable. And they have a goal to ensure reliability for quicker person-to-person payments. So let's try to discover some additional information here. So let's try to isolate the journey, the expectation, and their dependencies. Journey. As a user, I want to send money quickly to a third party. Makes sense in modern day payment-to-payment world. Expectation. I should receive a notification that the payment is being processed. Okay, let's try to maybe we might have to understand that a little bit more. What does being processed mean? But we have a good general idea of what we want to shoot for. Dependencies. There's a third-party application gateway, a clearinghouse, and a screening. These are somewhat reasonable. Being a card processor, they're not in the business of taking in interactions from consumers and users directly. They have to take it from a third party. And, oh, hey, since we're sending money around, it has to go through a cleaning house, and you'd have to do some screening processes there as well. So these seem completely reasonable. So here's the service architecture diagram for when I first met with Fortress Bank. You can see several services here proposed, talking to each other. And after some discussion and discovery, it was identified we needed to bifurcate this into two distinct journeys. Remember when I said before about we had to try to figure out something a little bit more of what it means for a transaction to be processed. So we broke it down. We went off and said, okay, there's a level 1 acknowledgement. Oh, hey, your payment is being processed. And then another notification when it's being completed. Great. And when we did that, we were able to say, oh, hey, the acknowledgement only really touches these service areas. So, hey, we start and stop our journey here. I'm not sure if it's how well you can see it, but there's start and stop arrows. You can kind of go around. They're numbered. You get the general idea. We're identifying the flow here. So we got this for our first one, our first acknowledgement here. And this was also isolated because there apparently is an SLA for this. They had an SLA for 99% of the time. Acknowledgement of the payment had to be processed and sent within 2,000 milliseconds. Pretty quick. And then the other journey here was that longer, oh, hey, your payment has been completed journey here. And you can see here, it goes all the way down and through, following a similar flow and going back out. This one only needed to take 30 minutes to process. But now we have, hey, what was once, let me flip back, hey, a really complicated architecture. When you're measuring the user journey, you can break it down into distinct components here. So you can break down the problem into sub-journeys and go from there. So that leads us on to our next thing here, measure success rates. Don't define bad behavior. Many organizations start out with error rates instead of success rates, and while it's true error rates are easier, and you get more traction in organizations to get going, and they're easier to grasp, but they also have limited scope, and they only inform you of outcomes of known undesired outcomes. They don't tell you stuff you're not already aware of that's a problem. So that's why I generally coach folks to get a better idea of define what are our known or successful outcomes, and then leave everything else be uncertain. And we can even flip this around a little bit. And let's take this and let's apply it back to our friends over at Fortress Bank. So with Fortress Bank, after we finally got the architecture down and pinned down and figured out a journey, we then said, oh, hey, let's do an availability metric based upon this. So in talking with them, we were able to isolate, hey, a portion of the requests that hit the Service Connect API must have at least 2, 3, or 400 HTTP status codes at the measure of the load balancer in order to be deemed successful. Now, I won't say this is right for all scenarios. This was right for their scenario. Some applications, based upon how things are architectured and things are set up to flow, there are some 400 error codes that should be not successful criteria. But for them, this is what was. So let's move on to our next point here. Provide raw data for SLOs. You generally don't want to downsample your data. You want to provide as much high fidelity information as possible to your SLO solution. Some folks, I think this is done with good intentions. They want to either average a query or do a percentile, maybe P95 of it or a sum of it. It's in the right spirit of creating an SLO and creating the correct objective. However, it's actually hampering additional insights you might have about that service. And it gets even more complicated when you have data sources that downsample the metric value as well. So you're not even sure, hey, if we're actually getting the whole P95 or so forth, or P50. So with this information, I'll introduce an SLO that hid some information. I was working with a different customer, but don't worry, we'll get back to Fortress Bank. And when they were able to gain additional insights once they stopped pre-aggregating their SLI. So this other company I worked with, they're in the entertainment industry, called Streams R Us. Again, names are made to protect the unreliable. They have, what's their motivation here? They have contractual requirements and strong competitive requirements. Who isn't in the streaming video business nowadays? There's so many different competitors in the marketplace. It's really important for these to be reliable in order to have a good user and customer experience. And they have a goal to ensure low latency in streaming video to their customers. So after spending some time discovering, designing, and implementing their SLOs, they started a cycle of reviewing them. And you can see the SLO here is clearly underperforming. I'm not sure how well it's showing up. But after a while, we were analyzing several one-off events and trying to dig into tracing and figure out what was happening and causing issues and why they were underperforming so much. However, just by looking at the SLI chart up above, it's the third one, the one up top, they were able to diagnose an issue just by noticing a rhythmic event, an event that was happening consistently every 24 hours that was affecting their end user latency. I would generally pause here for a moment, but I'm not sure the resolution is so good on the video, so I'm just gonna skip forward here and give you a little answer here. So every 24 hours, their cache would refresh at exactly the same time of day and trigger a 30 to 40-minute spike in latency. And that was contributing greatly to them underperforming here. They had several other issues as well, in that they were having to actually try to meet their target of availability, high latency here, or low latency. But this was a way to start trying to get back some nines. Something that consistently that was happening every day. And sometimes when you're working with your infrastructure and trying to figure out what to do next, you have to kind of go off after those events that, hey, we know this is happening, we need to go and do this and make it so. And again, they weren't even aware of this dependency for caching until they actually started looking at their SLI chart and stopped pre-aggregating that data. Next, we move on to the next section here, understanding expectations of system behavior. So we already have a good idea that we're measuring the right signals. Now what do? This is where we have to dive in and figure out where would be proper objectives, proper action, and proper time windows for our SLOs. So I generally recommend folks first to look back to look forward. Picking an objective is hard. But for existing services, it's generally a good idea to go and pull on historical data. I can't tell you how many times I've heard some people go off and say, all our services need 5 nines of reliability or better, without having the data or the business case to back it up. And this is where I feel when it comes time to pick an objective, it's important to understand several factors. How reliable does a service need to be competitive? How much unreliability can we handle with the current design? How much are we willing to spend to achieve these goals? See, when you analyze previous performance benchmarks, you understand what reliability targets are actually obtainable and which are just a pipe dream. Do we really need 5 nines if no one complained after we had an incident and we were down for an hour? Maybe not. Speaking of incidents a little bit, after an incident is also a great time to review the SLOs you've created and ask, did this SLI capture activity? Did it burn budget? And it's also a good time to ask, if it didn't burn any budget, are we really measuring the right things? Maybe we should go back and adjust this. It's also important to evaluate how much excess error budget is left when pushing new features. Or maybe, maybe you could do something like run a couple chaos experiments to try to be more reliable in the future, be more proactive instead of reactive. So most importantly, it's just important to, hey, review your SLOs and look back at the historical data here to try to help better understand and define what objectives are achievable. So going back to our friends at Fortress Bank, I've already mentioned before the SLA, where they had these contractual obligations for that user journey, where 99% of the time they had to send the acknowledgement of the payment is being processed within 2,000 milliseconds. We then asked them to go back to go look at their existing data and see how long the fastest 50th percentile transactions took. And to our surprise, it was lightning fast 100 milliseconds. Pretty quick. When we went off and did that, we had them also apply a label here, lightning, steady state. We then said, oh, hey, let's back into it some more. Let's look at the P90. We looked at the P90 and the behavior, and it was around 1,000 milliseconds. So that seems like a reasonable objective, something that was, performative. Great, this is something that's okay. We don't have to do any action, it's just maybe a little slowed down. Going further, we then defined laggy behavior. Hey, something's starting to go wrong. Maybe we set a P95 at around 1,500 milliseconds here. Oh, hey, maybe this is when we have to start, maybe it's putting in a service now incident. Likewise as well, we also have the P90 value of 1,000. So hey, maybe when we're starting to lag, maybe we should use something different here. It's the end of the day, what you're really doing is codifying your reliability standards based upon the historical data. What's actually achievable and what's not. And we could follow the same pattern for the other user journey we mentioned before, just different timescales. Look at the P50, oh, it was around 4.5 minutes. 5 minutes seems like an appropriate objective here, something we can meet. 90th percentile, 15 minutes, okay. And 92nd percentile at 25 minutes, oh, hey, something's going wrong here. Maybe we want to do something here. And astute viewers will also notice that I added in a new blob up top here, the external API gateway. This was, again, another dependency that wasn't discovered until we actually started to map out the user journey and actually start getting into telemetry and pulling down historical data. We were able to find another dependency here that they didn't know that they existed. And I was already been working with this team weekly for about 2.5, 3 months by this point. And again, as you start digging into the data, you find and discover more motivations, more insights, enhancing your mental model of what's actually going on with your systems that you're responsible for. Next up, I think I saw some quotes on this on Twitter earlier today. Observability without action is just storage. SLOs are living, breathing ideas. That shouldn't just be a bunch of things that are set it and forget. Yet another dashboard for the sake of creating additional dashboards out there. They're a method of codifying your service's reliability targets, and naturally your runbook should be tied to these observability solutions. I would also recommend setting up automatic actions to be taken, especially if your objective's in the neighborhood of four or 5 nines of reliability. You need to take that automated action, not dependent upon people to respond to a page, go off and do it. By the time that happens, you've already burnt all your budget for the year or whatever. You need to start tying in your runbooks and the actions you want to take to remediate your reliability into your observability solutions. And if you also want to look at this from the other end, you should only alert and page and take action when it's absolutely necessary. So with that in mind, let's flip back to Fortress Bank. So here, we have our different targets for latency over here on the side. And you can clearly see as well, we added in some additional columns now for the different actions we want to take. We codify our objective, we give it a label, something that's a bit easy for people that maybe have had their hands off the keyboard a little bit in the past few years to understand, and then tied to an action. When it's lightning, it's steady state, we don't do anything. When we hit the P90, when it's okay, the service, maybe we want to warn the team. Send a message on Slack to the team Slack channel. Just give them a heads up, hey, something might be happening. Next up, we're starting to lag. Oh, hey, low priority service now ticket, let's put it in. But then, oh, hey, if we start in danger of breaching our SLA, full outage and crisis mode. Let's actually let's take more definitive action and get all hands on deck to resolve this. So with that in mind, different time windows for different folks. SLOs aren't only for operations and SREs. Different personas or groups of people take different actions towards your reliability. They might call them KPIs. They might have different polling intervals. but overall they're making an effort to take in data to make decisions. Here it's important to consider introducing SLOs, utilizing the same SLI but different time windows for different audiences or different personas. So we have a few different personas here listed out here. The SRE and operational folks, they generally need to be concerned about the past 48, 24-hour rolling windows and take immediate action to make the service available and reliable. Maybe they're going to roll back. Maybe they're going to do exponential backoff, fail over, maybe set up some internal rate limiting, disable costly non-essential services, etc. They have a whole bunch of, run a runbook. They have a whole bunch of different tools in their kit in order to store and resolve service immediately. Other folks, the development team, they generally want something aligned to their sprints, rolling 14-day windows, 2-week calendar aligned windows, maybe something aligned to their sprint cycles when they do planning. They could use these SLOs to better help those teams make decisions to focus on whether they should focus on bugs or new features. Then you have your architecture and leadership teams that generally like to review services on a monthly or quarterly time frame. They tend to make more structural changes to your reliability. They generally ask questions like, do we need to be deployed in another region? Should we set up automated retries? Would it be more reliable if we started using technology XYZ, whatever the new hotness is on Hacker News? We need to, or a more serious conversation, we need to talk to our third-party vendor about them contributing towards our unreliability. Different folks, different personas take different actions to your reliability, and you need to be cognizant of that when you're designing your SLOs. Good rule of thumb here is think about the different actions different folks will take and how they want to receive it. I will say that these personas aren't complete. I'm sure there's other blends here. There's maybe another persona around a customer success manager or someone, a technical sales lead. And maybe there's another one around the CEO or the executive team. You know, maybe they have different time windows with different objectives and so forth, but overall, you know, I think it's some blend of these three main personas here in which they would use. And again, we're talking about the same SLI here, the same high value signal that we looked at before. We're just looking at it at different time windows with different error budgets. So they take their actions they take have different effects over that reliability. So quick note here. For folks that have issues trying to think of what else can I do to improve my reliability, I always recommend r9y.dev. And this screenshot just didn't come through too well. It's a really good breadth-first approach to reliability. Everyone go to r9y.dev on your phones and check out the reliability map. There's several swim lanes going across, and then different reliability targets going up and down here. The different reliability targets be different nines, 1 9, 2 9, 3 9s, 4 9s, up to 5. And then there's different swim lanes here about your tech stack, your observability stack, what infrastructure you have, your operations teams, and your different, and what resources the human factor you could do to support them. Think cultural items here. So if you're ever looking for, hey, a breadth-first approach of what I need to do to be more reliable, check out r9y.dev. Moving on to our next section here. Recognize when a system doesn't meet those expectations. So we have the right signals. We have some good objectives, actions, and corresponding time windows now. What else could there be? How we process those signals, how we document them, how we review them and learn for continuous improvement. So dashboards are both wonderful and terrible at the same time. And I feel a lot of what dashboards need to be not terrible is to have additional context applied to them. You know, they shouldn't just be a bunch of squiggly lines and bright colors. They should give proper context into the state of reliability of a service. You know, show of hands, who's ever inherited a service from another team? Yeah. How many times have you received a dashboard with that service as well when you inherited it? How many times have you received several dashboards once you inherited that service? Yeah. You know, it's a problem that we have. And a lot of it is you have to take in and view, hey, is this information current? Is it accurate? What's the signals this dashboard is telling me I should do and take action with? And you need to add in a lot more context to them in order for them to be effective for people to understand it. So with dashboards, you know, first thing, naming. I know it's like the hardest problem in computer science, figuring out how to name stuff. But you should try to adopt a taxonomy that your organization already utilizes and leverage that. And hey, and if you can't do that, hey, maybe just provide enough linking and context so that people can better understand what's being said there. I think a good measure here is if you can't understand what it means when you're paged at 3 a.m., then it probably isn't a good name. So you need that immediate recognition to understand what's going on. Another thing with dashboards, there should be annotations on charts. I would love to see more annotations for deployments, start and end of an incident, when an objective or parts of an SLO were changed, when actions were taken for these services, when we auto-scaled, when we rolled back, when we backed off, when we ran a certain playbook. This provides so much more information and context of what has already been done to help improve the reliability. It also gives, it also is very handy when you want to do that operational service review with your director or VP, every month or every quarter. It gives that additional context. Hey, this is what we did to try to remediate it. Instead of writing out a huge doc, hey, go look at this. Go see this. This is what we've done, and it's all automated and done with webhooks, without people being interacted and doing it themselves, without toiling away. You can still toil and do it, add in a couple things here or there, but you should try to push towards that. Next, badges. You need badges for when your SLOs are at risk. Large amount of burnt budget, when an SLO has been missing or provided unexpected data. But more importantly, when were they last reviewed? When were they affirmed to be important and accurate? In my mind, that's the biggest downfall of dashboards. You don't have that date it was last reviewed on there. And then lastly, dependency mapping. If a service is having issues, and you not only need to look up and down, but you also need to look across. What other services could be affected? Maybe even automatically annotate, hey, my sister team or sister service is having an issue, put that on my charts as well. So we could see, oh, hey, this is when they declared an incident and had an issue. How did that affect me as well? So next, document your SLOs. How often have you asked yourself, think back when you inherit that service, what is this service? Who is it responsible for it? Where is it deployed? How do we fix it? Why are these metrics even important? When you're creating your SLOs, it's important to document the who, what, when, where, how, and why for an SLO's existence. Ideally, these should be documented in Markdown. Bonus points if you could actually document these and have them tracked and versioned alongside your SLO definitions and your code. And with this, I'd like to give a shout out to SLO DLC. The service level objective development lifecycle is a repeatable methodology for creating metrics in a matter to service-centric organizations. So what's great about SLO DLC is that it's a bunch of templates that are all in Markdown that are designed to keep your reliability definitions tracked and versioned alongside your code base. As you make changes and update your code and your infrastructure, you also need to change and update your reliability definitions of what you're saying is our goals. And then you also need to update why we've changed and adjust those as well. And then our last tip here, your problems aren't unique. Dangerous to go alone. Don't operate in a silo. If you're having issues incubating and evangelizing SRE and observability culture, remember there are other people there to help you. There are several open standards and frameworks and communities of practice that you can adopt and join. And just here's a short list of ones I enjoy and value. You can see here for standards, OpenTelemetry, OpenSLO. Frameworks, Dora, R9YDev, SLO DLC. Communities, learning from incidents, Art of SLOs, Slacks, Devopsdays, of course, SREcon, Hangops, RAND's leadership, reliability.org. There's also socials as well. Several subreddits, tech Twitter if that's still going to be a thing in the future, Mastodon, some folks over at Blue Sky enjoying life as well. There's a bunch of people out there you could go out and get more ideas and definitions and more how can I help incubate this culture and make it a reality and not just a pipe dream. And with that, I want to say thank you, everybody. You've been a wonderful audience. If you'd like to chat, feel free to find me and let's talk. I'm also open to questions now. You'll see on the left over here is a QR code for my LinkedIn. Feel free to add me. And on the right is a video I've done more about communities of practice with Steve McGee at Google. It's talking about the different options there are for people and how to actually get them more involved in incubator and SRE culture. So with that, thank you.